Chapter 1: Getting Started. Version control systems are tools that track the history of changes to a set of files. They let you revert to previous versions, compare changes over time, and see who introduced a specific change. These systems evolved from local tools that only worked on one computer to centralized systems that used a single server to store the project history. The problem with a centralized system is that if the server goes down, no one can work. Git is a distributed version control system, which means every developer has a complete copy of the project's history on their own machine. This makes it faster and more resilient, as you can work offline and have multiple backups. Git was created by Linus Torvalds for developing the Linux kernel, with a focus on speed and efficiency. The most important concept to understand about Git is that it thinks about data as a series of snapshots. When you save your work, Git takes a picture of what all your files look like at that moment. This is different from most other systems that store a list of changes for each file. Your files in a Git project can be in one of three states. They can be modified, meaning you've changed the file but haven't saved it to the repository yet. They can be staged, meaning you've marked a modified file to be included in your next save snapshot. Or they can be committed, meaning the changes are safely stored in your local repository. These states correspond to three areas: the working tree, your project files, the staging area, where you prepare your next snapshot, and the Git directory, the repository itself. Before you start using Git, you need to configure your name and email address. This information is attached to every snapshot you save, so it's a crucial first step. Chapter 2: Git Basics. You can start a Git repository in two ways: by running git init in an existing project directory, or by running git clone to copy a repository from a server. The basic workflow involves making changes to files in your working tree. You use git status to see which files have been modified. To prepare a file for the next snapshot, you use git add, which moves it to the staging area. The .git ignore file lets you tell Git to ignore certain files, like temporary build files. You can see the specific changes you've made with git diff, and the changes you've staged with git diff-staged. Once you're happy with the files in your staging area, you run git commit to permanently save that snapshot to your project history with a descriptive message. If you make a mistake, you have several ways to undo it. You can amend your last commit to change its message or add files you forgot with git commit-amend. You can unstage a file with git reset head file. And you can discard all changes in a file back to its last committed state with git checkout-file, though this is a destructive action that should be used with care. To collaborate with others, you work with remote repositories. You can list your remotes with git remote, fetch changes from a remote with git fetch, and push your own changes with git push. The git pull command is a convenient shortcut for fetching and then immediately merging the changes. You can also create tags to mark important points in your history, like a version v1.0 release. Tags can be simple pointers or annotated tags that store extra information like the tagger's name and a message. Chapter 3: Git Branching. Git's branching capability is one of its most powerful features. A branch is just a simple, lightweight pointer to a specific commit. This makes creating and switching between branches incredibly fast. When you start, you're on a default branch, usually named master. The head pointer always points to the branch you're currently working on. When you create a new branch, you're just creating a new pointer. When you switch to it and make a commit, only that branch's pointer moves forward. This lets you work on new features or experiments in isolation without affecting the main line of development. When you want to integrate the work from one branch into another, you use git merge. If the branch you're merging is a direct descendant of your current branch, Git performs a fast-forward merge by just moving the pointer. If the branches have diverged, Git creates a new merge commit that has parents from both branches. Sometimes, if changes in both branches conflict, you'll have to manually resolve the merge conflict before completing the merge. It's common to use short-lived topic branches for individual features. You create a branch, do your work, merge it into your main branch, and then delete the topic branch. This keeps your main branch history clean and organized. When working with remotes, you'll have remote tracking branches like origin/master, which are read-only pointers to the state of branches on your remote server. An alternative to merging is rebasing. The git rebase command takes the commits from one branch and reapplies them one by one on top of another branch. This results in a much cleaner linear history. However, there is a golden rule. Never rebase commits that have already been pushed to a public repository that others are working with, as this can create significant confusion and problems for your collaborators. Chapter 4. Git on the server. To collaborate with a team, you need a shared, remote Git repository. You can set one up on your own server or use a hosting service. There are several protocols for Git to transfer data. HTTP/S is the most common today because it's easy to use and works through firewalls. SSH is also very common, providing secure, authenticated access. Less common are the local protocol for repositories on the same machine and the Git protocol, a fast but unauthenticated option. Setting up your own server involves creating a bare repository, one without a working directory, using git clone-bare. The simplest setup is to give your team SSH access to a server where you've placed this bare repository. For a more user-friendly experience, you can set up a web interface. Git Web is a basic viewer that comes with Git. For a full-featured solution, you can install something like GitLab, an open-source platform that offers repository management, code review tools, issue tracking, and much more. If you don't want to manage your own server, you can use a third-party hosting service like GitHub or Bitbucket. These are easy to set up and maintain, but require you to host your code on someone else's servers. Chapter 5. Distributed Git. Because Git is distributed, it allows for more flexible collaboration workflows than centralized systems. Common workflows include the centralized workflow, where one repository is the central hub for everyone, the integration manager workflow, where contributors work on their own public copies, forks, and ask a maintainer to pull in their changes, and the dictator and lieutenants workflow, used by huge projects like the Linux kernel, which has a hierarchy of managers who integrate code from different parts of the project. When contributing to a project, it's important to follow good practices. This includes making sure your commits are logical, separate change sets, and writing clear, well-formatted commit messages. A good commit message has a short, descriptive subject line followed by a more detailed body explaining the what and why of the change. How you contribute depends on the project. For a small, private team with shared access, the workflow can be very similar to a centralized one. For larger teams, you might work on feature branches that are then reviewed and integrated by a dedicated person. For public projects you don't have direct access to, you typically fork the repository, push your changes to your fork, and then submit a pull request to the original project. For some projects, especially older ones, you might contribute by generating patches and sending them via email. Chapter 6. GitHub. GitHub is the most popular hosting service for Git repositories. It's built around a collaborative workflow centered on pull requests. First, you set up an account, add your SSH keys for secure access, and enable two-factor authentication for security. The standard GitHub flow involves forking a project to create your own copy. You then create a topic branch, make your changes, and push it to your fork. From there, you open a pull request to the original project. This creates a forum for discussion and code review. If the project maintainers request changes, you can simply push new commits to your branch and the pull request will automatically update. This back-and-forth conversation is a key part of the GitHub workflow. GitHub has several useful features to enhance this process. You can cross-reference issues and pull requests, create task lists in your comments to track progress, and use a special version of Markdown to format your comments with code snippets and even emoji. When working on a project, it's also important to keep your fork up to date with changes from the original, upstream repository. You can do this by adding the original repository as another remote and periodically merging its changes into your own branches. GitHub also supports organizations, which are shared accounts for groups and companies. These allow you to manage repositories and access permissions through teams. Chapter 7. Git Tools. Git offers a variety of powerful tools for more complex situations. You can refer to commits in many ways, not just by their full 40-character hash. You can use a short, unique prefix, branch names, or the ref log, which tracks where your head has been. You can also use special syntax like cap and sim to refer to parent commits and ancestors. For staging changes, Git add p allows you to interactively choose which parts of a file to include in your next commit. This is great for creating focused, logical commits. If you need to switch branches but have unfinished work, Git stash temporarily saves your changes, allowing you to return to a clean working directory. You can reapply these stashed changes later. Git clean is used to remove untracked files from your working directory. You can also cryptographically sign your work using GPG to verify its authenticity. Git provides powerful tools for rewriting your history, but these should be used with caution on commits that have already been shared. Git commit-amend lets you modify the last commit. Git rebase-I allows you to interactively reorder, edit, or combine multiple commits. Git filter branch is a more powerful and dangerous tool for rewriting large parts of your history. The git reset command is used to undo changes by moving the head pointer. It has three main modes: -soft, which only moves the pointer, -mixed, the default, which also updates the staging area, and -hard, which also overwrites your working directory and can lead to lost work. For managing dependencies, Git submodule allows you to include other Git repositories as subdirectories within your main project. Chapter 8. Customizing Git. You can tailor Git's behavior to your preferences and workflows through configuration settings and custom scripts. The git config command allows you to set options at 3 levels: system-wide, for your user account, global, or for a specific repository, local. You can customize your default text editor, create templates for commit messages, and control the use of color in the terminal. You can also configure Git to use external graphical tools for viewing differences and resolving merge conflicts. Git attributes, defined in a .git attributes file, let you apply settings to specific files or directories. This is useful for telling Git how to handle binary files, setting up custom diff logic for specific file types, like Word documents, or managing line-ending issues between operating systems. Git hooks are scripts that automatically run at certain points in Git's execution cycle, like before a commit, pre-commit, or after a push is received on a server, post-receive. Client-side hooks can be used to check your code style or run tests before committing. Server-side hooks are powerful for enforcing project policies, such as requiring commit messages to follow a specific format or restricting who can push to certain branches. Chapter 9. Git and Other Systems. Git can coexist with and import from other version control systems. If your team uses Subversion, you can use Git SVN as a client. This allows you to use local Git features like branching and the staging area while your changes are committed to a central Subversion server. Similarly, tools exist to use Git as a client for Mercurial and Perforce. If you're ready to switch to Git completely, there are tools to help you migrate your project. Git SVN Clone can import a Subversion repository's history. For other systems, there are often dedicated import tools. If a tool doesn't exist for your system, you can write a custom script that uses Git Fast Import, a powerful command that reads simple instructions to build a Git repository from scratch. This allows you to migrate from almost any system, preserving your project's history. Chapter 10: Git Internals. This chapter looks under the hood to explain how Git actually works. Git's commands are divided into porcelain, user-friendly, and plumbing, low-level commands. At its core, Git is a content-addressable file system. It stores everything in an object database in the .git/objects directory. There are 4 main object types. A blob stores the raw content of a file. A tree represents a directory containing pointers to blobs and other trees. A commit points to a tree and stores metadata like the parent commits, author, and commit message, forming the project's history. A tag object points to a commit and gives it a permanent, friendly name. Since remembering the 40-character SHA-1 hashes for these objects is impractical, Git uses references, or refs, which are simple files that store these hashes. Branches and tags are just different types of references. The special head reference points to the current branch you're working on. To save space, Git periodically packs objects into a single compressed pack file. It uses delta compression, storing some objects as just the difference from other similar objects. The ref spec is a mapping that tells Git how to handle references when fetching from or pushing to a remote. Finally, Git uses 2 main protocols for transferring data: a simple but inefficient dumb protocol over HTTP, and a more common and efficient smart protocol that works over SSH or HTTP and involves a Git-aware process on the server to negotiate what data needs to be transferred. That's all for this episode of Geek Capsule. We hope it gave you a fresh perspective on the world of technology. We'd love to hear your thoughts, so feel free to leave a comment or share your feedback. If you enjoyed the show, don't forget to subscribe and join us next time for another essential read. Until then, keep your curiosity sparked and your mind open.